Hey guys, welcome back. We are going to finish up lesson 3.5. So let me present my screen and we'll jump right into the problems. Okay, so if you remember, we were talking about nonlinear systems, all right? And we did some solving by graphing. We did some solving by, that was just looking at the solution, substitution, and then elimination. Okay, so we're just going to do a little bit more of each of those examples and then one word problem. All right, I think I'm doing the evens tonight. All right, so the first one, solved by graphing. Let me first darken my X and Y axis. So here is my, oh, I want that to be black. Why did not go to black? There we go. Here is my Y-axis, and here's my X-axis. All right, so the first equation is quadratic. Y equals X minus 2 squared. Hopefully it reminds you of that vertex form, AX minus H squared plus K. So you should be able to look at it and identify the vertex as 2, 0. All right, the A value is just a 1, so it opens up and there's no vertical stretch or shrink. So 2, I said 2, 1, but I wrote 2, 0. So 2, 0 is here. And it's going to go out 1, up 1, out 1, up 1, then out 2, up 4, out 2, up 4. All right, and we'll draw our nice parabola. Okay, and the other equation, it appears to be linear, so let me write it down. Y equals 1/4 X minus 1/2. Hopefully that reminds you of Y equals MX plus B, where your slope, your M, is 1/4, rise over run, and your B, your Y-intercept, is -1/2. So I'm going to go down to -1/2 on the Y-axis and plot a point. And then the slope is up 1/4. So up 1/1, 2, 3, 4. And then I'm going to go down 1 to the left 4. Down, oh, sorry guys, that's not in the right spot because I forgot where my Y-intercept was. So ignore that point. Let me see if I can erase it. Let me try that again. I wasn't counting correctly as I was graphing. So remember, you're at 1/2. So up 1 would be up here, right? Halfway between 1 and 2. So that's up 1 and then over 1, 2, 3, 4. So I'm like more kind of right, trying to get it where it belongs, about there. Okay. And then from here, I'm going to go down 1 and then over 1, 2, 3, 4. Come on. There we go. All right. So then you draw your line. Did I not graph it correctly? Why is this not where I want it to be? Let me see one more time. Oh, no. Did I? No, that's right. Y-intercept is -1/2. And then I went up 1. Over 1, 2, 3, 4. Oh, I see what I need to do. Okay, I'm not wrong. I just was not thinking about it clearly. All right. So you can see that the line and the parabola do intersect somewhere around here. It looks like probably right there. And this is where I was thrown off for a second. So my slope that I used was up 1 unit and over 4 units. Well, instead of going up 1 unit and over 4, let's just go up half that amount. So if I go up, instead of up 1, go up a half a unit. So you're right on the x-axis. You're right at the origin now. Instead of going to the right 4, go to the right 2, 1, 2. Then you land right there at that point, which is where your vertex is. So even though that wasn't an original point that I plotted along the line, I could tell that the parabola and the line were intersecting. So I had to think about how else could I use slope? You know, you could divide this number by a half and this number by a half. So instead of going up 1, I went up a half of a unit. Instead of going to the right 4, I went up half of that, so I went to the right 2. All right, in any case, you can see that they intersect at 2, 0. Okay. Again, everything is always easier when I'm doing this on actual graph paper and not using this pen to try to do the math and the graphing, because it's hard to get the point exactly where I need it to go. But hopefully you're doing it by hand and you could see what I couldn't see at first. Okay. All right. So that was number 2. Let's jump to number 4. So number 4 says, solve the system of nonlinear equations by using the graph. So again, I'm just looking for where do they intersect? So they intersect right here at this point, and they intersect over, trying to get it where it's supposed to be, right here at that point, okay? So they intersect at this point, which has a coordinate of over 2 down. It looks like we're counting by 2, 4, 6, 8, 10. So it's over 2 down 10. And this point has a coordinate of, well, if this is -2, so -1, and then -2, 4, 6, 8, 10. All right. All right, so that was number 4. Let's move on to number 6. So solving by substitution. So for substitution, you always want one of the variables by itself. In this case, you have 2 variables. You have y by itself, and you have this y by itself as well. All right, you could plug this in for the y up here, or you could think of plugging this in for the y in the other equation. You'll actually get the same equation no matter what. So you're either plugging this in for this y, or you're plugging this in for this y. In any case, you're going to get an equation that says x plus 4 equals x plus 2 squared plus 1. We're going to clean this up, so we have to do the distribution. Don't forget your equal signs. So you have x plus 2 times x plus 2, right, because we're going to FOIL. So I have x plus 4 equals x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4, and then that plus 1. Combining like terms on that right-hand side, you have x squared plus, that's going to be 4x plus 5. Let's set the equation equal to 0. It appears to be quadratic, and if it's quadratic, we typically want to set it equal to 0 and then talk about the different strategies for solving. Oop, cross those out. So I have 4 equals x squared plus 3x plus 5. Subtract 4 from both sides. So now I have 0 equals x squared plus 3x plus 1. All right, so let me bring this up here. I have x squared plus 3x plus 1 equals 0. So typically at this point, I'd say, okay, let's try to guess and check, reverse FOIL. All right, x times x is x squared. What 2 numbers multiply to 1 and add to 3? There are none. This problem can't be solved by factoring. So if it can't be solved by factoring, you either have to complete the square or a quadratic formula. And it's really up to you. I typically use quadratic formula before complete the square. Again, it's just my preference. Maybe if this number was even and divisible by 2, I do completing the square. I mean, again, it's really up to you. If you like the completing the square method, go for it. All right. But I'm going to use quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I have x equals, the b value is a 3, so -3 plus or minus the square root of 3 squared minus 4 times the a value is 1 and the c value is 1 all over 2 times a, which is 1. Clean that up a little bit. I'm going to have -3 plus or minus the square root of 9 minus 4 times 1 times 1 is 4, all over 2. I have to clean that, or give myself more room over here. Hopefully you guys can just keep working down your page because you can write smaller than I can with this pen. All right, so now I have x is equal to -3 plus or minus the square root of 9 minus 4 is 5 all over 2. 5 does not have any perfect square factors. There's no negative under the radical. There's no fraction under the radical. So we're completely simplified. That is your final answer. Now, I said that's your final answer. That's your final answer for the x value. You still need to find the corresponding y value. And this is not too crazy. It looks crazy because we're not used to having to plug in something like that for x, but watch what happens. It's not too bad. I'm going to take the first equation. Y is equal to x plus 4. Well, x is this value. So I have -3 plus or minus root 5 over 2 plus 4. Now, to add fractions, I need common denominators. Right now, 4 turns into a fraction by writing 4 over 1. So I have to multiply top and bottom of this fraction by 2 so that I have common denominators. So now it's -3 plus or minus the square root of 5 over 2 plus 8 over 2. All right. Now that I have common denominators, I'm allowed to add my numerators. So I'm going to have -3 plus or minus root 5 plus 8 all over 2 is one answer. Well, actually, I'll leave it like that for now. All right. So I'm going to combine like terms, -3 plus 8, that's going to give you a 5. So I have 5 plus or minus root 2 over 2. Okay, so your x value is -3 plus or minus root 5 over 2, and your y value is 5 plus or minus root, I changed that to a 2. That's supposed to be a 5, guys. That's a 5. Plus or minus root 5 over 2. And that would be your ordered pair. Now, before you panic, I don't often give problems that look this crazy as far as final answers are concerned, but just know the math behind it was not super challenging. You just had to get common denominators to add your numerators together. Okay. All right. That was number 6. Number 8 has a nicer answer. So let's move on to number 8. So again, you're solving by substitution. So you're looking for a variable that is isolated. I see that this y is isolated. So I can substitute this expression in for the y of the other equation. The goal is to get one equation with all the same variables. So the first equation becomes 2x squared plus 10x plus 48 equals -4x squared minus 16x minus 10x. Right, I just continue to copy. All right, so there looks like there are some like terms to combine. So let's do that first. So I have 2x squared plus 10x plus 48 equals -4x squared. And that's going to give you -26x. It looks like it's going to be quadratic because I see x squares. Let's set it equal to 0. So let's move everything on the right-hand side over to the left-hand side. I'm going to add 4x squared. And at the same time, I'm going to add 26x just to try to get 2 steps done at the same time. So all this ends up canceling, which is good. So I have 6x squared plus 36x plus 48 equals 0. It is quadratic. I look for my GCF, which is a 6. All right, 6 goes into 6 once, 6 goes into 36 6 times, and 6 goes into 48 8 times. And then I try to factor what's inside the parentheses by using reverse FOIL, guess and check. What 2 numbers multiply to 8 and add to 6? A +4 and a +2. Now you're going to use the zero product property. You're going to set the factors that involve an x, these two factors here, equal to 0. You don't set your GCF equal to x because it wouldn't, you don't set your GCF equal to 0 because there is no x. It wouldn't make sense to say 6 is equal to 0. That's not true. So you can't do that. But you're going to have x plus 4 equals 0 and x plus 2 equals 0. Subtract 4, so x equals -4. Subtract 2, so x equals -2. Remember, the answer is going to be an ordered pair. Right now, I know the x values are -4 and -2. I have to find the corresponding y value. So you have to plug the x value back into one of the two equations and solve for y. I'm going to use the second equation. So I have -4x squared minus 16x equals y. Sorry, forgot what I was copying for a second. Plug the -4 in. So -4 and then times -4 squared minus 16 times -4 equals y. -4 squared is 16. 16 times -4 is -64. -16 times -4 is a positive 64. And then equals y. -64 and positive 64 is 0. So I just found the corresponding y value. Okay, now I have to do the same thing for the other coordinate. All right, so I'm going to again take this equation, -4x squared minus 16x equals y. I'm solving for y by plugging -2 in for x. So -4 times -2 squared minus 16 times -2 equals y. -2 squared is +4. +4 times -4 is -16. -16 times -2 is going to be +32. And then combining like terms, you get 16 equals y. Okay, so here's one answer. And here's the other answer. Okay. All right, let's keep on moving along. So number 10, solve the equation by elimination. Oh, this one's nice. Look, the y's are already lined up. The x squares are lined up. The x's are lined up. And the constants are lined up. The other ones we had to like rearrange. So today's problem is easy. So I'm going to subtract my equations. Now, if you don't want to subtract, because oftentimes we're always adding. We're always adding. If you want to add, that's fine. But then you have to multiply one of the equations through by a negative. So if I multiply this second equation through by a negative, that's negative, that's negative. This would become positive, and this would become positive. That is very messy. So you know what? I'm going to just rewrite the equation underneath. So if I multiply this equation through by a -1, it becomes -y equals -x. Try this again. Give myself a little room. -y equals -x squared plus 8x plus 19. The reason that I like to multiply through by a negative, let's try to imagine that's not there, is because adding the equations and eliminating often allows students not to make many sign errors. All right, so 9 plus -1 is an 8x squared. 6 plus 8, that's going to be a 14x. And 19 plus 2 is a 21. Okay. All right, so for this one, we could try to factor, but I already know it's not going to factor, so we're going to skip that step. We could try the quadratic formula, but before we go through the entire quadratic formula, actually, we'll just do it. I was going to try something different, but we'll just do it. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I'm going to have -14 plus or minus the square root of 14 squared plus 14 oh, not 14, sorry. I started copying what was above instead of, okay. So plus 4 times A, which is 8, times C, which is 21, all over 2 times A, which is 8. Okay. So when I simplify, I'm going to have negative 14 plus or minus. Now grab out your calculators, all right, because these are pretty large numbers to do all this multiplication. Okay, 14 squared plus 4 times 8 times 21. Tell me what you get. Oh, and I made a sign error. Sorry, guys. This should be minus. I kept looking up here instead of here when I was copying down. So this right here, I'm just going to do it in black. There should be a minus, not a plus. That's going to change your answer quite drastically. All right, so go ahead and do 14 squared minus 4 times 8 times 21. And you'll get a negative 476. Okay, all over 16. Now, because this is negative, what does that mean about your solution? It means it's imaginary. So there's no real solution. Okay, there's no real solutions or solution. And for these problems, we are looking for real solutions. Okay, so we don't have to go any further. All right. Okay, and I think we just have one more problem to do, number 12. So for this problem, it says the sum of two numbers is, the sum of two numbers is negative 5, and the sum of the squares of the two numbers is 17. What are the two numbers? Explain your reasoning. So we have two unknowns, right? We're going to have two variables. We're going to let x equal the first number that we don't know, and we're going to let y equal the second number. So it says the sum, meaning addition, of two numbers is, means equals negative 5. So x plus y equals negative 5 is how you turn that into an equation. Then it says, and the sum of the squares of the two numbers, so sum still means addition, square, we know what that looks like, right, is equals 17. So that would be x squared plus y squared equals 17. What are the two numbers? Explain your reasoning. All right, so you could try to solve by elimination, but this one really, I would suggest doing substitution, isolate a variable. So you can get this x by itself or this y by itself. Okay, I'm going to get the y by itself by moving the x to the other side, subtracting it. So I have y equals negative 5 minus x. Now I'm going to substitute that value in for the y of the other equation. So the other equation becomes x squared plus negative 5 minus x squared equals 17. I'm going to have to FOIL, right? So let me write that out. X squared plus negative 5 minus x, negative 5 minus x equals 17. So I have x squared negative 5 times negative 5 is a positive 25. Negative 5 times negative x is a positive 5x. Negative x times negative 5 is a positive 5x. Negative x times negative x is a positive x squared equals 17. Okay, lots of combining to do. X squared plus x squared combined like terms is 2x squared. 5x plus 5x gives me 10x. Then I have my plus 25 equals 17. I'm going to move the 17 over so I can set it equal to 0. So I have 2x squared plus 10x. Move the 17 over by subtraction, so that'll leave me with a positive 8 equals 0. Okay, so let me write that up here. So I have 2x squared plus 10x plus 8 equals 0. All right, get rid of all this for now. All right, so let's try to factor out the GCF first. X squared plus 5x plus 4 equals 0. Then we'll try to factor by guess and check. Hopefully that'll work so we don't have to do like quadratic formula or something. So I have x times x. Factors of 4 that multiply to 4 but add to 5 are 4 and 1. Right? 4 plus 1 is 5. 4 times 1 is 4. Set these equal to 0, the zero product property. And you get x is equal to negative 4. Negative 4. And you get x is equal to negative 1. Okay. All right. So when I erased my equations. I was like, where did my equations go? Hold on. Let me write those equations back up that we had at the beginning. So my two equations, two relationships were x plus y equals negative 5 and x squared plus y squared equals 17. Okay. So when x equals negative 4, when x equals negative 4, what's y equal? Well, y, right, I can figure it out by plugging into this equation. Negative 4 plus y equals negative 5. Add 4 to both sides, so y equals negative 1. Okay, so when x is negative 4, y is negative 1. That's one answer option. Now, when x equals negative 1, right, because that was the other answer you got, we got to figure out what y is equal to. I'm going to use the same equation here. So negative 1 plus y equals negative 5. Add 1 to both sides, and you're left with y is equal to negative 4. So when x is negative 1, y is negative 4. Okay, so going back to the original question, it says, what are the two numbers? The sum of the two numbers is negative 5. If I add these two numbers, I get negative 5. And it says that the sum of the squares is 17. Well, negative 4 squared is 16. Negative 1 squared is 1. 16 and 1 gives me 17. And I can do the same thing over here. These two numbers add to negative 5. Negative 1 squared is 1. Negative 4 squared is 16. Add the 16 and the 1, and you get a 17. Okay, so there are two answer options for that problem. All right, that is it, guys, for lesson 3.5. We only have one more lesson for this chapter, and then we'll be moving on to chapter 4. But I'll meet you back here for lesson 3.6. Bye.